Saleh. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Mazidah binti Muhammad Salman. In this video, I will present about subnetting ipv4 addressing using packet tracer along with my group mates Azhar, Syasya, and Muadz. Alright, in this project, we will build a network based on this given topology. In this topology, we can see the customer network has several subnets. We will consider the size of the subnet and also future expansions when we choose the subnetting scheme. Therefore, we will create the subnetting table to specify addresses range so that we will be able to configure host PCs, switches, and router interfaces. At the end, we will do connectivity tests using ping command. Next, I will pass to Azhar.
Okay, my name is Muhammad Azharuddin Bin Azmi. So I will present about method of subnetting. Let us look at the network requirement. So how many subnets do we need? Based on the requirements given by the customer, we need at least 4 subnets. Subnet LAN A with 50 host IP addresses. Subnet LAN B with 40 host IP addresses, and 2 additional unused subnets for future expansions with no specific of host IP addresses. Customer does not want variable length subnet mask. Now, we are ready to find out the most suitable subnetting scheme to use in this project. We need to answer 2 important questions. First, how many host addresses are needed in the largest required subnet? LAN A has 50, LAN B has 40. Therefore, the answer to this question is 50 host addresses must be available in the subnet. Second, what is the minimum number of subnets required? 4 subnets. The customer told us we need 4 subnets. So, in short, we need 4 subnets with the size of at least 50 host addresses. We were given the subnet 192.168.0.0 bracket /24 network. The subnet mask is /24 equals to 255.255.255.0. Therefore, in binary, the subnet mask is 11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11.11. ones represent the network's portion and the zeros represent the host portion. We subnet a network by borrowing enough bits from the host portion. But how many bits from the host portion we want to borrow? Let us do 1 bit borrowing from the host portion. The subnet will be 11 11 11 11 point 11 11 11 1 point 11 11 11 11 point 1 0 0 0 0 0 0 0. From this, the subnet has already changed from 255.255.255.0 to 255.255.255.128, and the number of bits borrowed from host portion is 1 bit. Therefore, the number of subnets created is 1 to the power of 1, 2 to the power of 1 equals to 2 subnets. Furthermore, the number of zeros available in the network in the new subnet mask is now left only 7 zeros. This means the number of hosts is equal to 2 to the power of 7 equals to 128 hosts. But we cannot use network addresses when the host ID part is all zeros, which is considered as network address, and all ones, which is considered as broadcast address. We need to minus 2. Therefore, 128 need to be minus 2 equals to 126 hosts. Should we stop subnetting? No, because we only have 2 subnets now. We need 4 subnets. Therefore, we need to borrow more from the host portion. Let us do 2 bits borrowing from the host portion. The subnet will be 11.11.11.11.11.11.11.000. From this, the subnet has already changed from 255.255.255.128 to 255.255.255.192, and the number of bits borrowed from host portion is 2 bits. Therefore, the number of the subnet created is 2 to the power of 2 equals to 4 subnets. Furthermore, the number of zeros available in the new subnet mask is now only 6 zeros. This means the number of hosts is equally to 2 to the power of 6 equals to 64 hosts. But we cannot use network addresses when the host ID part is all zeros, which is considered as network address, and all ones, which is considered as broadcast address. We need to minus 2. Therefore, 64 need to be minus 2 equals to 60 hosts. Should we stop subnetting? Yes, because we already have 4 subnet now. The minimum number of subnet requirement of the project is also 4 subnets. Our largest subnet needs only 50 hosts. This is less than 60 available host addresses, so it meets the required number of minimum host addresses. The subnet that meets both the minimum number of subnet required and the required minimum number of hosts is this one, 255.255.192. So we will continue to Syasya.
Okay, let us now list all the 4 subnets. Remember, we borrow 2 bits from the host portion. 192.168.0.0, this is the first subnet. The 2 borrowed bits from the host portion to become part of its network portion is 00. The prefix is /26 and the subnet mask is 255.255.255.192. Therefore, the range of addresses is 192.168.0.0 until 192.168.0.63. The first one, 192.168.0.0, and the last one, 192.168.0.63, cannot be used to assign to host or PC or gateway because they are known as subnet address and also broadcast address. Addresses between the two can be used to assign to hosts 192.168.0.1 until 192.168.0.92. 192.168.0.64. This is the second subnet. The two borrowed bits from the host portion to become part of its network portion is 01. The prefix is /26 and the subnet mask is 255.255.255.192. Therefore, the range of addresses is 192.168.0.64 until 192.168.0.127. The first one, 192.168.0.64, and the last one, 192.198.0.127, cannot be used to assign to host or PC or gateway because they are known as subnet address and also broadcast address. Addresses between the two can be used to assign to hosts. 192.168.0.65 until 192.168.0.126. Next, 192.168.0.128. This is the third subnet. The two borrowed is from the host portion to become part of its network portion is 10. The prefix is /26 and the subnet mask is 255.255.255.192. Therefore, the range of addresses is 192.168.0.128 until 192.128.0.191. The first one is 192.168.0.128 and the last one 192.198.0.191. 191 cannot be used to assign to host or PC or gateway because they are known as subnet address and also broadcast address. Addresses between the two can be used to assign to host 192.168.0.129 until 192.168.0.190. Okay. 192.168.0.192. This is the first net. This is the first subnet. The two borrowed bits from the host portion to become part of its network portion is 11. The prefix is /26 and the subnet mask is 255.255.255.192. Therefore, the range of addresses is 192.168.0.191 until the 168.0.255. The first one is 192.168.0.192 and the last one 192.168.0.255 cannot be used to assign to host or PC or gateway because they are known as subnet address and also broadcast address. Addresses between the two can be used to assign to hosts 192.168.0.193 until 162.168.0.254. Okay, now we should assign the first subnet for LAN A and the second subnet for LAN B. The third and fourth subnet are reserved for future use. We will follow this standard rule of configuration. First, use the first host address for the customer router interface connected to LAN A or LAN B. Second, use the second host address for the LAN A or LAN B switch. Make sure to assign a default gateway address for the switch. Third, use the last host address for PCA or PCB. Make sure to assign a default gateway address for the PC. So this is the addressing table. With the topology and this addressing table, we are now ready to go to the packet tracer to actually configure the customer network. Let's go.
Okay, my name is Muadz bin Shamsul Kamal. I will show step by step how to build the network. First, open packet tracer, and then drag and drop routers, switches, PCs, and servers. Now go to the network devices, go to routers, pick the 2901 router. Two routers. We follow the topology. LAN A, LAN B, switches. There are 3 switches on this topology. Then 2 PCs and 1 workstation. PCA, PCB, workstation, ISP workstation, and ISP server. Then connect them using the right transmission media. So go to connections and pick the copper straight through cable and connect the router to the switch. Just use the copper cable. Most of them are using the copper straight through cable. Just the router, connect router to router, it uses the different cable. Okay, now I'll connect all of them using the copper straight through cable. Okay, now connect the server to the switch, ISP switch. Connect the workstation to the switch. Now connect the switch to the router, ISP switch to the ISP router. So the router will use the serial DCE cable. But before that, we must click on the router. Turn the power off. Take the HWIC dash 2T and put in the port, and then turn back on the switch. Same for the ISP router. Turn off the power. The HWIC dash 2T and put in the port. Now turn back on the power. Okay, now we are done. Now take the serial DCE cable and connect the both routers. Okay. Now I will rename all components according to the topology. First, the router. Go to config and display name customer router. And I will rename all the components in this topology. ISP router. Okay. This is LAN A switch. LAN A switch. LAN A switch. And this is LAN B switch. And this is PCA. According to the topology, this is PCA. And then this is PCB. And this is ISP switch. ISP workstations. ISP workstation. This is ISP server. Okay, now it looks the same as the topology. Okay, now we will configure the router. First, click on the router and and write the command of enable. Okay. Now enable configure terminal. Okay, now host name. We will change the host name to customer router. Host name customer router. Okay, now it already changed the host name. Now we will configure according to the addressing table. Okay. First, we will look at the interface. We just move the mouse to the here, and it will show us the port gig 0, gigabit Ethernet 0/0, 0/0. So go to the CLI. Interface gigabit Ethernet 0/0. Okay. Now we will configure the interface using the IP address 192 IP address 192.168.0.1. Subnet mask 255.255.255.192. 255.255.255.192. Okay. Success. No shut down. Exit. Okay. Now we configure the Second interface. It's 0/1. So go to the command interface. Command line interface and okay, configure the IP address of interface 0/1 is 192.168.0.65. 0.65. Or one IP address 168.168.0.65. Subnet mask 255.255.255.192. 255.255.255.192. 192. Okay. No shutdown. Exit. Now we will configure the serial port 030. Go to the command line interface. In S serial 0/3/0. Okay, we'll configure the interface. Check the IP address 209 dot point 165.165.201.2. Subnet mask. Oh, I forgot the IP address again. IP address 209.165. 209.165.201.2. Subnet mask 255.255.255.252. 255.255.252. Okay, success. We need to clock rate. Set the clock rate to 128.000. Okay. No shutdown, exit, exit, show run. Okay, we will look. We already successfully configured the router. Okay, now we go to the next router. First, we will set the host name to ISP router. Enable, configure terminal. Host name, ISP router, ISP router. Okay, we already set the host name. Now we will configure the router. Check the port gigabyte 00. Gigabit Ethernet 00. Yeah, 00. So go to the CLI interface, gigabit Ethernet 0/0. Okay, configure it. IP address. Check the IP address at the addressing table. ISP router 209.165, 209.165.200.225. Subnet mask 255.255.255.224. 255.225.224. Okay, successful. No shutdown. Exit. Now we will configure the serial interface. So 0/3/0. INT interface serial 0/3/0. Okay, we'll configure the interface. IP address. IP address. IP address for the serial is 209. 209.165.255.224. 0.165 point 201.1 0.201.1 subnet mask 255 255 255 252 255 255 252 252. Okay, success. No shutdown. No shutdown. Exit. No shutdown. Exit. Exit. Show run. Okay, now we'll check if we successfully configured it. Yes, we successfully configured it. Okay. Now we successfully configured the routers. Now we will configure the switch VLAN 1. The switches of VLAN 1. Go to the LAN A switch. We change the host name first. Host name, enable, and then enable, then configure terminal. And then host name, LAN A switch, LAN A switch, LAN A switch. Okay, we successfully configured the host name. Now we'll configure the interface according to the IP addressing table. Interface VLAN 1, VLAN 1, okay. Then VLAN 1, and then okay, we configure interface mode, IP address, IP address 192 192.168.0.2. Subnet mask 255 255 255 192 255 255 255 192 192 192 successful. No shutdown. Exit. Now we set the default gateway. We configure the default gateway. So IP default gateway 192.168.0.1. 192.168.0.1. Oh, okay. Successful. Exit. Now, show run. Okay, we will see if we successfully configured the IP address and default gateway. Yes, it is successful. Okay. Moving to the LAN B switch, still B1, VLAN 1. Go to the CLI. First, we change the host name first. Enable. Enable. Configure terminal. Configure terminal, and then host name. LAN B switch. LAN B switch. LAN B switch. Okay, we successfully changed the host name. Now we will configure the interface. What is the interface? This is LAN B switch. Okay. Interface VLAN 1 IP address. According to the addressing table, LAN B switch is 192.168.0.0.66. And the subnet mask is 255, 255, 255, 192, 192. Or I have 192, 192. Forgot the point. Okay. Success. No shutdown. Shutdown. No shutdown. Exit. Now we want to configure the default gateway. Mistake. Wait. Ni yang salah komen. Komen macam mana nak bagi? Oh dah. Okay, now we will enable it again. Configure terminal. IP default gateway. We will set it to according to addressing table. 192.168.0.65. Okay. Exit. Show run. Okay, we'll check if we successfully enter the IP address and subnet mask and also the default gateway. Yes, we successfully configured the LAN B switch VLAN 1. Okay, now we'll move to the ISP switch. ISP switch, we have to configure the hostname first. So enable, configure terminal, hostname to ISP switch, ISP switch. Is it right? Yes, we successfully configured the hostname. Now we configure the ISP switch interface VLAN 1 IP address 209.165.165.200. 0.226.226 subnet mask 255.255.255.224 224 Okay. Okay, successful. So no shutdown. Exit. Exit one more time. Okay. Now, uh, uh, now show run. Okay. We successfully IP address. So the configuration of the switch is successful. Okay. Now we go to the PC and devices. PCA, PCB, ISP workstation, ISP server. So first, put the default gateway here. Look at the addressing table. PCA 192.168. Point 0.1. 0.1 PCA default gateway, and the IPv4 address is 192.168.0.62. Subnet mask. Like that. Wait. 192.168.0.62. Is successful. 255.255.255.192. Okay, successfully configured the PCA. Now PCB, default gateway. And PCB 192.168, 192.168 point PCB 0.65. The IP address, go to fast Ethernet. IP address is 192.168.0.0.126.126. 255. The Subnet mask is 255.255.192. Okay, we successfully configured the PCB. Now we configure the ISP workstation. ISP workstation. Default gateway 209. 209.165. 09.165.200. 0.225. 0.225. Go to fast Ethernet. To 5 to 00 165.09. Okay, go to the set the IP address 209 209.165.200.235. Subnet mask 255.255.224. 224. 224. Okay, successfully configured the workstation. Now go to ISP server. Default gateway. Two 209.165.200.225. 0.225. Now we go to the fast Ethernet. Fill the IP address according to the table. 209 200.200.240. Subnet mask 255.255.225.224. 224. Okay, we successfully configured the ISP server works. The ISP server. Now we will go to the connectivity test that Mazidah will present.
All right. To test the connectivity, we will do the connectivity for ping from PCA to its default gateway. Ping 192.168.0.0 Point 1. The result for ping from PCA to its default gateway is successful. Next, we will do connectivity test for ping from PCB to its default gateway. Ping 192.168.0.65. The result for ping from PCB to its default gateway is successful. And lastly, we will do connectivity test for ping from PCA to PCB. Ping 192.168.0.126. The result for ping from PCA to PCB is successful. That's all from us. I hope that my teammates and I have effectively explained about subnetting IPv4 addressing using packet tracer to everyone. Thank you very much.
We hope you enjoy our presentation. Thank you, madam.